Good evening. In today's session, I am going to explain you some more problems given on system of particles, in particular on moment of inertia in previous JEE main. Let's move on to the problems. Look into the first problem. Look here. Consider two uniform discs of same thickness of different radii and same material. Ratio of their moments of inertia respectively are given as I1 is to I2 is equal to 1 is to 16, and it is mentioned in the problem R2 is equal to alpha R1. We need to find the value of alpha. First of all, for a disc, what is about the natural axis? If the axis is not mentioned, we just take it as natural axis. For a circular disc, what is the formula for moment of inertia about an axis passing through the center perpendicular to the plane? How much? It is m r square by 2. You are right. So, I is equal to m r square by 2. And here they didn't mention anything about the mass, they just mentioned about radius. So, try to find out the relation between mass and radius of the disc. So, mass is equal to volume into density, pi r square t d. See here, t is the thickness, because in the problem same thickness it is mentioned, same material, so density is also same, from which mass is proportional to r square. So, in place of mass we can take the proportionality. So, I proportional to r square into r square, r to the power of 4, right. So, r proportional to I to the power of 1 by 4. So, R1 by R2 is equal to I1 by I2 to the power of 1 by 4. So, how much will it be? R1 by R2 is equal to 1 by 16 to the power of 1 by 4 is 1 by 2. Now, you are supposed to find the value of alpha here. So, from this R2 is equal to 2 R1, that is what we got from this expression, but he mentioned R2 is equal to alpha R1. If you just compare, alpha is equal to 2, that is the answer. So, first option is correct for that problem. Okay, move on to the next problem. Look here, linear density of a thin rod of length L varies with the distance as per that equation. Find the moment of inertia of the rod through the end and perpendicular to the length of the rod. See here, let this be a rod, right, of length capital L and mass capital M. You are supposed to find moment of inertia of the rod about this axis passing through the end point perpendicular to the length. If it is a uniform rod, we can already we derived the expression, we straight away write the expression for moment of inertia about the end point about an axis passing through the end perpendicular to the length as ml square by 3. But it is not a uniform rod, that is the most important thing. It is mentioned that the linear mass density varies with length like this. So, here it is mentioned linear mass density is given as lambda naught into 1 plus x by L, that is mass per unit length of the rod. Now, consider a small element of thickness dx at a distance x from this end. So, mass of that element will be lambda dx. Mass of the entire rod will be integral lambda dx 0 to L, that is 1. Moment of inertia is m into dx square. See, moment of inertia is mass into x square. Okay, this is moment of inertia, limits are from 0 to L. So, in place of lambda, we substitute this expression, that is lambda naught into 1 plus x by L. Lambda naught into 1 plus x by L x square dx integral. Let us expand this. Lambda naught we can take it as outside because it is a constant factor. So, x square plus x into x square x cube by L dx. Right? Let us integrate that. What do we get? I is equal to lambda naught into x square integral is x cube by 3. X cube integral is x to the power of 4 by 4. X to the power of 4 by 4 L. Limits are from 0 to L. Just to substitute that, you get lambda naught into L cube by 3 plus L to the power of 4 by L is L cube by 4. If you take 12 as LCM, 4 plus 3 into L cube. So, 7 by 12 lambda naught L cube is the moment of inertia in terms of lambda naught. If you look at the option, there is no lambda naught, it is given in terms of mass. So, let us try to find out the lambda value in terms of mass. So, here this is the total mass is equal to integral lambda dx. Lambda naught into 1 plus x by L dx. So, lambda naught into x plus x square by 2 L, 0 to L. If you substitute, m is equal to lambda naught L plus L square by L is L by 2, meaning m is equal to L plus L by 2 is 3L by 2, 3L by 2 into lambda naught, from which lambda naught is equal to 2 by 3 m by L. Lambda naught is equal to 2 by 3 m by L. So, I is equal to 7 by 12, lambda naught is 2 by 3 m by L into L cube. So, this gets cancelled, L square times, this gets cancelled 6 times, I is equal to 7 by 6 3s are 18 m L square. That is the moment of inertia. So, this is option B. Okay? So, you have to learn this model perfectly well. There are so many similar problems given in previous JEE. Move on to the next problem. Look here, almost similar one. Mass per unit area of a circular disc varies with the distance as per the equation. Find the moment of inertia of the disc about an axis passing through the center perpendicular to the plane, that is the natural axis. Let us consider this as a circular disc. This is the center. Let this be a small element of thickness dx. Let the thickness of the element be dx and it is at a distance x from this, or as the distance is given as r, let it be r and this distance is small r. Okay. Now, mass is equal to sigma into 2 pi r dr because here mass per unit area it is given as sigma. So, here for that element area is 2 pi r dr. So, mass of that element is sigma 2 pi r dr. Moment of inertia is integral m r square, isn't it? M r square. In place of m, let us write this sigma 2 pi r dr into r square. So, this is sigma 2 pi r into r square is r cube dr. Now, let us substitute sigma value. sigma varies with distance as a plus br. So, this is a plus br into 2 pi r cube dr. So, here we can take that 2 pi as a common factor because it is constant outside. A r cube plus b r to the power of 4 dr. Limits are 0 to a because radius of the disc is given as a here. So, integrate this. I is equal to 2 pi is taken as a common factor. A r cube integral r to the power of 4 by 4 plus b r to the power of 4 integral r to the power of 5 by 5, and given the limits are 0 to a. So, if you substitute the limits 2 pi a to the power of 4 by 4 plus b a to the power of 5 by 5. So, you can take that a to the power of 4 as a common factor. 2 pi a to the power of 4 a by 4 plus a, there is one a left here, a b by 5, that is the expression for moment of inertia of that circular disc about an axis passing through the center perpendicular to the plane. Okay, it's nice, isn't it? So, what is the correct option for that? 2 pi a to the power of 4 a by 4 plus this one. Okay, that is the correct option for that problem. Move on to the next problem. Look here, a thin circular plate of mass m, radius r, has its density as, this is also similar model, given as a rho naught into r, where rho naught is constant and r is the distance from its center. Moment of inertia of the circular plate about the so here moment of inertia, just now we have seen m is equal to mass per unit area into area of the elementary part, that is 2 pi r dr into r square. So, here you can take the common constants outside. 2 pi rho naught can be taken outside, r square, r to the power of 4. So, r to the power of 4 dr, right. So, here I is equal to, as a rho naught is given as a constant factor, it is 2 pi rho naught r to the power of 5 by 5. Its integral is r to the power of 5 by 5. Limits are from 0 to, what is the radius? Radius is given as r. So, 0 to capital R. So, this is 2 pi rho naught r to the power of 5 by 5. That is the moment of inertia we got. But here answer is not expressed in that form. It is given as alpha mr square. So, this rho naught has to be eliminated. See here, mass is equal to integral sigma 2 pi r dr, right. Sigma is given as rho naught into r, rho naught r 2 pi r dr. So, 2 pi rho naught can be taken as common factor. 2 pi rho naught integral r square dr, or 2 pi rho naught r cube by 3 after substituting the limits also. So, from this we can directly replace this. 2 pi rho naught is equal to 2 pi rho naught is equal to 3m by r cube. Substitute this in this expression, implies I is equal to, what is the value of 2 pi rho naught? 3m by r cube. 3m by r cube into r to the power of 5 by 5. This is moment of inertia is equal to r cube gets cancelled, r square times in r power 5. So 3 by 5 m r square. That is the moment of inertia here. So what is the value of alpha asked? In place of alpha, we got 3 by 5. That is the, no. Look here very carefully. This answer is wrong. About an axis passing through the edge. But this is about an axis passing through the center. Now, look here very, very carefully. This is moment of inertia of the disk about an axis like this, passing through the center perpendicular to the plane. But he asked passing through the edge and perpendicular to the plate like this. So here, suppose if this is the axis, you have to imagine a parallel axis like this, and this distance is r. I is equal to Ig plus mr square. So here this is Ig, because we found the moment of inertia of the disk about an axis passing through the center perpendicular to the plane. But here he asked moment of inertia of the plate about an axis perpendicular to the plate passing through the edge. Tangential axis perpendicular to the plate is asked. So this is Ig is 3 by 5 mr square plus mr square. So the answer is 5 plus 3 is 8. So 8 by 5 mr square. See, you have to be very, very cautious here. So this edge has to be identified. Otherwise, instead of getting 4 marks, we will be losing 1 mark altogether. We will be losing 4 marks because of the negative, 5 marks because of the negative mark. So it is very important to underline or to identify the conditions, keywords. Here the keyword is, you are supposed to find the moment of inertia about an axis perpendicular to the plane passing through its edge. Okay. So this is the answer. Move on to the next problem. See here, two identical spherical balls of mass m, radius r are stuck on the ends of the rod of length 2r, mass, moment of inertia of the system about an axis perpendicular to the rod passing through the center. Look here, two identical spherical balls. We take them as, if it is not mentioned, we consider the spherical balls as solid spheres. So for this one, about this axis, I is equal to Ig plus mr square, where r is the perpendicular distance between this axis and the natural axis. For this also, because both of them are having the same mass, same radius. So for that also the same formula, so into 2. And ends of a rod of length 2r and mass m. Mass for a rod of mass m, length L, about an axis passing through the center perpendicular to the plane, it is m L square by 12. So first you have to understand that. Moment of inertia of this sphere about the natural axis is Ig plus mr square, where r is this distance. For this also Ig plus mr square, as the two spheres are identical and they are at the same distance from the axis under consideration, just we multiplied that with 2. And this is a rod of mass m, length 2r. So for any rod of mass m, length L, moment of inertia about an axis passing through the center perpendicular to the plane is ml square by 12. So Ig, moment of inertia of a solid sphere, 2 by 5 mr square plus m. What is this distance from this? This is r and this is r, this is 2r. So m into 2r whole square, that is 4r square. And there are two such kind of spheres, plus m into Length of the rod is 2r. 2r whole square is 4r square. ml square by 12. So, we can take this as mr square can be taken as a common factor outside. If you bring this 2 inside, this becomes 4 by 5. 2 4s are 8. This becomes 1 by 3. 1 by 3. Let us take the LCM. So, here mr square into 5 3s are 15. 3 4s are 12. 15 8s are 120. Right? 15 8s are 120 and this is 5. So, what is here? This is mr square into 120, 132, 137. 137 by 15, that is the answer. So, here moment of inertia of the system about an axis perpendicular and passing through the center of the rod, it is 137 by 15 mr square. Okay, here the interesting thing is the rod is kept at the edges. So, from the center of the sphere to this point, the distance is r plus r, we have to take it as 2r. That is the important point to be registered properly. Now, look into this. Equilateral triangle ABC is cut from a thin solid sheet of wood. D, E, F are the midpoints of its sides are shown and G is the center of the triangle. Moment of inertia about an axis passing through G perpendicular to the plane of the triangle is I0. If the smaller triangle is removed from the center, what is the moment of inertia of the remaining figure? So, here moment of inertia of the bigger triangle is given as I or I0, and from this exactly the central part is removed. What is the moment of inertia of the remaining part? So, moment of inertia of the remaining part about that axis is I0 minus moment of inertia of the removed part about the same axis. So, moment of inertia is proportional to m into k square, where k is the radius of gyration. See here, and that radius of gyration once again depends on the side of the triangle. See here, if the original mass is taken as m, mass of the removed part, this is the removed part. Exactly, there are 4 identical triangles, 1/4 mass is removed. So, mass of the removed part is m by 4. If length of side length is L, this side length it becomes L by 2. So, removed part length is L by 2. So, as moment of inertia is proportional to m into k square, if this is I0, mass becomes 1/4, k square as side becomes half, k square is proportional to L square, hence it becomes 1 by 2 whole square. So, moment of inertia of the remaining part is I0 into 1 minus 1 by 16, or it is 1 minus 1 by 16 is 15 by 16. So, this is the answer, 15 by 16 I0. Okay? Move on to the next problem. Look here, it is interesting. A circular disc, this is a circular disc of mass m, radius r, has 2 identical discs of mass m, radius r arranged like that. Moment of inertia of the system about this axis passing through the center center of this disc D1. See here, the disc is arranged like this and the axis is like this. The 2 discs are arranged like this at the end. So, for this disc, this axis becomes, that axis becomes axis passing through the center perpendicular to the plane. So, its moment of inertia is mr square by 2. Now, next disc is like this axis is like this. So, this axis becomes a parallel axis through the diameter of the disc. So, about the diameter of the disc, moment of inertia is mr square by 4. Ig plus m into square of the distance. So, the distance between this disc and this is nothing but the radius of the disc. So, this is mr square. For this also exactly the same, because these two discs are identical. So, for the central disc, this axis is perpendicular to the plane passing through the center. For the two discs arranged at the end, axis is like this, which is parallel to the diameter of the disc. So, mr square by 4 plus mr square into 2. So, here mr square by 2 plus, if you take LCM, 5 mr square by 4 into 2. So, this gets cancelled 2 times. So, 5 plus 1, 6 mr square by 2, it is equal to 3 mr square. So, moment of inertia I is equal to 3 mr square. That is the correct answer for that problem. Okay, let us move on to the next problem. Look here, a wheel of radius 0.2 meters rotates freely about its center when a string that is wrapped over its rim is pulled by a force of 10 Newton as shown. Established torque is 2 radian per second square. Moment of inertia of the wheel. See here, torque is R cross F, that is also equal to I alpha. R cross F means RF sin theta, where theta is the angle between R and F. If R and F are perpendicular, torque becomes, sin theta becomes 1, so RF. See here, this is the radius, this is the force. So, radius is given as 0.2 meters. So, 0.2 meters, and the force is given as here, it is mentioned here also 10 Newton. You are supposed to find the moment of inertia if angular acceleration produced is 2 radian per second square. See here, I is equal to 2 by 2, that is 1 kg meter square. That is the correct answer for that problem. It is simple. RF is equal to I alpha. Look into this problem. M is the mass of the bigger disc, R is the radius of the disc, a portion of radius R by 3 is removed from it. What is the moment of inertia of the remaining part about an axis passing through the point O and perpendicular to the plane of the disc? Actually, it is given as 4 by x mr square. You need to find the value of x here. So, moment of inertia of the remaining part is moment of inertia of the original object minus moment of inertia of the removed portion about the original axis considered. See here, first I is moment of inertia of the disc, that is mr square. Now, moment of inertia of the removed part. See, I'll write them separately. So, I is the moment of inertia of the disc about the axis passing through the center perpendicular to the plane, that is mr square by 2. Okay? Passing through the center perpendicular to the plane. IR is, look here, we need to find its moment of inertia about this axis, Ig plus mr square. See here, Ig, mass of this part, as mass is proportional to r square, as radius is r by 3, mass is m by 3, r by 3 whole square is r square by 9. So, it becomes mass proportional to r square m by 9. So, here mass of the removed part becomes m by 9 and radius is r by 3. So its moment of inertia becomes m by 9 into r square by 9, that is Ig, plus mr square. So mass is m by 9, r is this distance. The total radius is r minus r by 3, that is 2r by 3 whole square. So here mr square by 89, 9 nines are 81. Sorry, mr square by 81 plus m by 9, 4r square by 9. So mr square plus 4mr square by 81, it is 5 mr square by 81, that is the moment of inertia of the removed part. Okay. So 4r square by 9, so 4 plus 1 5, 5 mr square by 81. Now you have to find the moment of inertia of the remaining part. So I dash is equal to I is mr square by 2 minus moment of inertia of the remaining part is 5 mr square by 81. 5 mr square by 81. So if you take LCM as 2 into 81, if you take mr square as constant factor, see here there is a mistake, isn't it? Mr square we have taken, so instead of correcting that, I will do one thing. Instead of correcting the calculation, you see here. So for this I have just taken mr square, but mr square by 2 for a disc. So this is mr square by 2 into 81 plus m by 81 into 4r square. Okay. So here mr square, if you take it as common factor outside 81 also, 1 by 2 plus 4, isn't it? 1 by 2 plus 4. 2 4s are 8, 8 plus 1 9 by 2. So removed part moment of inertia is mr square by 81 into 9 by 2. This gets cancelled, 9 times mr square by 18. So moment of inertia of the original disc is mr square by 2. Moment of inertia of the removed part is how much? Look here. This one, isn't it? How much? Mr square by 18. This is mr square by 18. So moment of inertia of the remaining is I minus mr square by 18. So if you take 18 as LCM, mr square as a common factor, 9 minus 1, it is 8 by 18. Mr square into 8 by 18. This becomes 4 by 9, right? So here we got the moment of inertia as mr square into 4 by 9, moment of inertia of the remaining part. But it is given as mr square into 4 by x. In place of x we got 9. So the value of x here is 9. So here a moment of inertia of the disc about this axis is mr square by 2. Moment of inertia of disc about this axis is m by 3 r by 3 whole square into half, because if m is small m is its mass, it will be mr square by 2 once again. That is what we have taken here. Actually that was the correction I made. Now look here very carefully. A, B, C are disc, solid sphere and a spherical shell. A is the disc, this is the disc, and B is a solid sphere, and this is a shell. Shell means a hollow sphere. See, they are placed like that, as shown in the figure. Moment of inertia of the given system about this axis, where I is moment of inertia of the disc about the diameter. I is the moment of inertia of the disc about its diameter. So, follow this very carefully. Moment of all of them, they have the same mass and radius. It is shown here that they have the same radius. They did not mention anything about mass. So, we have to assume they are of equal masses. Now, look here. Let us consider three objects like this: a disc, a solid sphere, a spherical shell, having same mass and radius arranged like that. You are supposed to find the moment of inertia about this axis. So, for the disc diameter, so I is equal to, I dash is equal to, just I want to have a sip of water. Look here, moment of inertia of the disc, that is mr square by 2. Moment of inertia of this solid sphere, that is 2 by 5 mr square, but this becomes the tangent plus mr square, plus moment of inertia of a shell, 2 by 3 mr square plus mr square, because that is the tangential axis. See here, mr square by 2 plus 7 by 5 mr square plus 5 by 3 mr square. So, let us take mr square as a common factor. So, LCM is 2 into 5 into 3, 2 into 5 into 3. Okay. So, here for this 5, 15, for this 2 into 3, 6 7s are 42, for this 2 5s are 10 into 5, 50. Okay. So, this is mr square by 2 into 5 into 3 into 50 plus 15, 65, 67, 107. Okay. It is 92, 97, 107 divided by like that. So, here mr square by 2, because I is given, where I is the moment of inertia of the disc, this is given as moment of inertia. So, I by 15 into 107. So, this is the moment of inertia of the entire system about this axis, but they gave it as x by 15. So, here the in place of x we have 107. So, x is equal to 107. Do you understand? So, moment of inertia of the disc, this axis becomes the diameter mr square by 2. For the solid cylinder, this axis becomes the tangential axis 7 by 5 mr square. For the spherical shell, this becomes tangential axis, that is 5 by 3 mr square. That is it. But here mr square by 2 is given as I. So, we have just replaced mr square by 2 with I. We got it as 107 I by 15, but they gave it as I by 15 into x. In place of x, the number is 107. Go to the next problem. Two iron solid discs of negligible thickness have radii r1, r2, moments of inertia are I1, I2 respectively. For r2 is equal to 2 r1, ratio of I1 and I2 would be. See here, moment of inertia is proportional to r to the power of 4, isn't it? In case of discs of same thickness, same density, moment of inertia I is equal to mr square. Mass of a disc is proportional to its area, that is r square into r square. So, moment of inertia is proportional to r to the power of 4. So, ratio of I1 by I2 will be equal to R1 by R2 to the power of 4. So, from this expression, R1 by R2 is 2R1 to the power of 4, implies I1 by I2 is equal to 1 by 2 to the power of 4, 1 by 16. But they gave it as 1 by x. So, in place of x, we have 16. So, x is equal to 16. That is the right choice there. Okay, move on to the next problem. Moment of inertia of a solid disc rotating about its diameter. Moment of inertia of a solid disc rotating about its diameter is mr square by 4. It is equal to 2.5 times higher than moment of inertia of a ring rotating in a similar way. And moment of inertia of a solid sphere which has the same radius as the disc. Let us take the radius of the disc as r1. So, moment of inertia of the solid sphere will also be equal to r1, and rotating in the similar way has n times higher the moment of inertia of the given ring. What is n here? So, m r1 square by 4 is 2.5 times the moment of inertia of a ring. So, 2.5 into m r2 square, given that all their masses are equal. Now, moment of inertia of a solid sphere. Solid sphere is 2 by 5 m r square. Here it is mentioned that moment of inertia of that solid sphere is also equal, radius of that solid sphere is also equal to radius of the disc, solid disc considered. So, 2 by 5 m r1 square is equal to n times moment of inertia of the ring about its natural axis. So, what is n here? So, if you divide this 1 by 4 by 2 by 5, 1 by 4 by 2 by 5 is equal to 2.5 by n, right. So, here this 2.5 get cancelled 2 times, 2 and 2 gets cancelled. So, n is equal to 4 here. That is the answer. So, n is equal to 4. Okay? That is the correct answer for this. Here very important thing is moment of inertia of a disc about its diameter. Moment of inertia of a disc about the diameter is m r1 square by 4. 2.5 times moment of inertia of a ring. So, moment of inertia of a solid sphere is n times moment of inertia of the same ring about the same axis. So, if you take this as a natural axis, this is also natural axis. From that we could get n as equal to 4. Look into this fourth problem. 3 balls of masses 2 kg, 4 kg, 6 kg are arranged at the center of edges of an equilateral triangle. That is a very, very important word. This is an equilateral triangle. The 3 particles of masses 2, 4, 6 are arranged at the centers of edges. So, 2 kg is arranged here, and then 4 kg is arranged here, and 6 kg is arranged here. Moment of inertia of this system about an axis passing through the centroid and perpendicular. So, this perpendicular distance is L by 2 root 3. All of them will be at the same distance. Distance of the center of each side from the centroid is L by 2 root 3. So, moment of inertia of that system is m1 r1 square plus m2 r2 square plus m3 r3 square. As all of them are at equal distances, it is m1 plus m2 plus m3, r3 is L by 2 root 3, L square by 2 root 3 whole square, that is 4 into 3 L square by 12. So here masses are 2 plus 4 plus 6 into length is given as 2 meters. So 2 square is 4 by 4 into 3. This is 12 by 3, that is equal to 4. So the answer is once again 4 kg meter square. So L by 2 root 3 whole square. So 2 root 3 whole square is 2 square into 3, 4 3s are 12. So that is the correct answer. Okay. Go to the next problem, last problem for today's class. Two identical spheres of mass 2 kg and radius 50 centimeters are fixed at the ends of a light rod. At the ends of a light rod, mass of the rod is negligible here, and the separation between the centers is given as 150 centimeters. Moment of inertia of the system about an axis passing through the center perpendicular to the rod is given by x by 20. Supposed to find the value of x here. So here 2 by 5, because the sphere's mass radius, we treat them, because they didn't mention that as shell, so we take them as solid spheres. So 2 by 5 mr square plus m into this distance L by 2 whole square, and we have two identical spheres under identical conditions, because both of them are at equal distances from the axis, so into 2. So here this is 2 by 5, mass is given as 2 kg, radius is given as 50 centimeters. So let us convert that into meter, 0.5, so 0.5 into 0.5 plus mass is 2 kg, length is given as 150 centimeters, 1.5 into 1.5 by 2 into 2, whole thing multiplied by 2. So here this gets cancelled 0.1 times, 2 into 0.5 is 1. So it is 0.2 plus 0.2 into 2 is there. So I am expanding the bracket here. So 2 into 0.2 plus this 2 and this 2 gets cancelled, this 2 that 2 gets cancelled, 1.5 into 1.5 is 2.25. So this is 2.25 plus 0.4, it is 2.65 kg meter square. It's quite interesting, see, but it is given as, we got it as 2.65 kg meter square, but they gave it as x by 20. So x is equal to 2.65 into 20. So this is 26.5 into 2, that is equal to 53 kg meter square. That is the numerical value given in the options. So that is the correct option, 53 kg meter square. So you have to do this, definitely you will be getting one problem from the same models, but what all you need to do is, while doing the calculation, while noting down the problem, you have to be careful. While noting down the problem, you have to concentrate on the keywords. While doing the problem, you have to concentrate on the calculation part. I'll stop here for today. I'll continue with some more problems in the next session. Thank you and bye-bye.